Hi everyone, and I welcome you all. This is a new topic which is called image compression. This image compression is something so relevant today. Now, how is it relevant, right? It's coronavirus going on, and we all are stuck here at our homes or wherever we are. I'm a student, and definitely, if some of you are watching, would also be a student, right? As a students, what we nowadays get, the teachers record their lectures on some platform, and later on they upload their videos on Drive or Google Drive, and they share the link with us. Now the problem is that those videos are so large. Like we get what 1.5 GB internet per day. And out of that 1.5 GB, just suppose that your teacher uploaded a video of 1 GB. You just have zero point 0.5 GB left. And even sometimes it's worse. We get 1.5 GB internet and they just upload the videos of 2 GB. Like it doesn't make sense at all, right? So what is the best option? Best option is definitely that they should upload the videos on YouTube, which is a very good option, I'll just say. And they can make it private, right? To whatever domain they have. Supposedly, my university name is ABC. So they can make it private to abc.edu, right? But that is a different story altogether. One also alternative is that we can go for something called as image compression or video compression. So what is this compression all about? So we'll just see today that what is this compression. Before doing this compression and everything, one thing I would like to tell you is something what is data and what is information. Once we know this aspect, we'll be able to explore image compression in a better way, right? So if I talk about data and information, many a times we just think of that data and information are two synonym terms, right? But mind it, make it clear, data and information are two separate things altogether. Totally separate things. Like, okay, one may depend upon other, but they are quite different. Now, for example, what happens is that the information remains same, but the amount of data required to represent that information may change. For example, here are there three examples given. See this example one. Your brother Rohit will meet you at IGI airport in New Delhi at 5 minutes past 6 p.m. tomorrow night. Another example, your brother, now they omitted Rohit, right? They omitted Rohit, will meet you at IGI airport at 5 minutes past 6 p.m. tomorrow night. Cool. The third example is Rohit will meet you at IGI at 6 p.m. tomorrow night. So, one thing which you just got is that information was conveyed, but what was different was the amount of data which was required to represent that information. So, the same information can be represented by different amount of data. Like, okay, just take another example. We use WhatsApp a lot, right? We are a generation, we use Instagram, Twitter, Facebook, and many things, right? So there gone are the times when you used to write YOUU. What we write, we just write a single letter U. If I'm okay, I have to write how are you. So HOW, small r, then small u. How are you? So what we are basically doing, that is text compression, which we are doing, right? So the information is same, but the data which is required to represent that information is different. But what do we try to do in compression is that we try to keep the information intact. The data can change, right? So you can just see over here, there was one information only which was explained in all three examples. What was different was only the data, correct? Now my data was different in all the three examples, but the information remains same. The information at the crux of all this was that okay, there is one brother Rohit, and you have to meet him in the IGI airport 6 p.m. tomorrow night. That was the only information, but there were three ways of telling it. Here they are just telling IGI airport in New Delhi. Here he is just not even mentioning the name, or he's not telling that IGI airport. And so of course it was quite understood. So in image compression, we move from this to this. This is just a form of text compression which is shown, right? But this is the crux of image compression. You need to know that in image compression or in any sort of compression, right? Forget image compression. Talk about text compression or any compression. Our main motive is that the information has to remain intact. The information must not be lost. The amount of data required to represent it can be varied, and it should be as minimum as possible. Like here in the example 3, the data was as minimum as possible, but the information was conveyed. That is a for sure thing, right? So let us come to this thing where it is written data compression. I have said you this, right? So try to read it and just have a parallelism what I said. Data compression refers to the process of reducing the amount of data required to represent a given quantity of information. So that is what is the concept of data and information. So from now on, data and information are not the synonym terms. Data is just the means by which the information is being conveyed. So this is a small point here I wanted to tell you in the beginning, that data is not equal to information. Data compression will aim to reduce the amount of data, preserving as much as information as possible. Now, because various amount of data can be used to represent the same amount of information, as we saw in the three examples, that how it was same amount of information but there was different amounts of data, the representation that contain irrelevant or the repeated information are said to be called redundant data. Correct? So when we try to go for compression, what we try to see is if there is any redundant data, we try to see that. Cool. Like here we just try to see that, okay, your brother, this is something quite obvious. Like I know the name of my brother, right? And this is also quite obvious. We know that IGI airport is in Delhi, so there is no means or there's no relevance in telling about this information. So this is what we try to do. We try to see the redundant data, and with that we try to keep my information intact. That is the crux. Okay, now let's take an example and try to understand that why is image compression so much important for us as of now, right? One thing, you are facing it right now. Like I need not to tell you, definitely this is a problem throughout, that teachers are uploading the lectures of 2 GB and all that, and our entire internet is gone there. They don't even bother to compress the videos or whatever images they share. They just upload it and send it. But still, let us just see numerically that how much this image compression is important for us. With the help of a numerical, let's try to see that how is it, right? Now here it is given that there is one person called ABC. He wishes to download the X-Men movie in 720p. So definitely we all know now what are these picture qualities: 1080p, 720p, 144p. So what does it basically p this stands for? This means 1 to 80 into 720 format. Actually, there is one ratio which is 16 is to 9. So if you try to maintain 16 by 9 is equals to x by 720, correct? So you will get x as 720 into 16 divided by 9. That will be 1 to 80. So 720p basically implies 1 to 80 into 720 format. The movie duration is 2 hours and it was recorded at 60 frames per second. So what I need to do is I need to calculate the amount of storage it would require to store, how many dual layer blue discs would be required to store this movie, and how much time will it take to transmit the video over a broadband connection having bandwidth capacity 100 Mbps, right? So we'll just see this in the next video. Till then, have a great time.